Okay, so let's look at some example problems for Chapter 5. If we look at the first one here, let me scoot it down a little bit. You want to go to grad school 3 years from now, and you can save $5,000 per year beginning immediately. So that means I need to change my calculator to begin mode. So I'm going to go over here and do that so I don't forget. So I go to second, let me clear that, start over second, begin, and then second set, and now I'm in begin mode. And then it says that you plan to deposit the funds in a mutual fund where you expect to earn 9% per year. Under these conditions, how much will you have after you make the third deposit 3 years from now? So 3 years from now is saying I need to find a future value. So I need to find the future value. Let me write down my other parts, NI and payment. And so the present value we don't need, it's 0 because this is an annuity that's paying $5,000 per year. So I could put 5,000 over here and I can make it a negative amount. The interest rate is 9 and N is 3 years. And so if I go over here, I put 0 in for the present value, 3 for N, 9 for the interest rate, and 5,000 negative for the payment. And I hit compute future value. And so I get $17,865.65, which is answer D. So let's go to the next one. Whoops. It's kind of hard to do with this little pen thing. Okay, so you have a chance to buy an annuity that pays $1,000 at the beginning of each year. So I know that over here, I'm still in begin mode, so that's fine, for 5 years. And I could earn 6% on my money and other investments of equal risk. What's the most I should pay for this annuity? So that means what's the present value or the price. So the future value is 0 because there's nothing that we'll have after that. The payment amount is $1,000 at the beginning of each year for N equals 5 years. And the interest rate they say you can earn is 6. So I'm going to leave my calculator in begin mode, and I'm going to enter in 0 for the future value, $1,000 for the payment, 5 is the number of years, and 6 is the interest rate. And if I hit compute present value, I get $4,000, 465.11. And so we get answer D. That's how much you should pay for this particular product. And then let's look at the next question. Now, I want to check and see if this is going to be in begin mode or end mode. So your father has $500,000 and wants to retire. He expects to live for another 20 years and to be able to earn 8% on his invested funds. How much could he withdraw at the end of the year? So I need to go back to my calculator and put it in end mode. So I'm going to go to second, the payment key where it says begin, and then second set to change it and hit clear. So I'll put down my keys, present value, future value, in payment, and I. So he has $500,000 today, and he hopes to invest it in a way that he can live on it for 20 years. So that means N is 20. And he wants to earn 8%, or he expects to earn 8%. And so how much could he withdraw? So in the future, at the very end, there'll be nothing left. So put 0 for future value. How much can he withdraw at the end of each of the next 20 years? And it says, and end up with 0 in his account. So I'll go over to the calculator, and I'll put 500,000, and it's an investment, present value, 0, future value, 20, N, 8, I, and then hit compute payment. And you get $50,000, 926.10. And that's answer E. So he'll be able to live on $50,000, or basically $51,000 a year. So let's look at the next one. Question 4. Okay, your girlfriend just won the Powerball lottery. She has the choice of $10 million today or a 30-year annuity of $500,000 with the first payment coming today. Okay, so it says with the first payment coming today, that means I need begin mode. So I'm going to go over here, second payment, second set, and clear. Okay, so I'll start writing out my stuff. Present value, future value, in, payment, and I. And it's saying what rate of return, so that means solve for I. Okay, so the present value is she could have $10 million today. And I'll just put that as a negative. Or she could have $500,000 a year. So it's kind of like considering, what if I made a $10 million investment and I got $500,000 as a payment every year for N equals 30 years. And at the end I'll have 0 left. So I need to go over to the calculator and put 10 million as my present value, 0 as my future value. Let's see, 30 in, and then 500,000 as the payment, and hit compute I, and I get 3.08%. And so that's answer B. So let's see about the next one. Okay, what's the rate of return you would earn if you paid $1,500 for a perpetuity that pays $105 per year? So the present value of a perpetuity is just a formula, and it's equal to the payment over the discount rate for the perpetuity. So I could solve for RP and say that the rate would be equal to the payment divided by the price, or the present value of the perpetuity. So R, the rate, is going to equal the payment, pays $105 per year, and the price is $1,500. So 105 divided by 1,500 equals 7%. And so that's answer B. So you can see this one, we don't use the financial calculator, we just use an equation. It's simple that way. And then let's look at number 6. An investment promises the following cash flow stream: $1,000 at time 0, $2,000 at the end of year 1, T equals 1, $3,000 at the end of year 2, and $5,000 at the end of year 3. At a discount rate of 5%, what is the present value of this cash flow stream? So I need to use the cash flow button on my calculator and enter these in, and then go to NPV and put I is equal to 5, and then hit compute. So just like you're saying, cash flow 0 is 1,000, cash flow 1 is 2,000, cash flow 2 is 3,000, and cash flow 3 is 5,000. So let me go to the calculator. I'm just going to go ahead and change this back to begin mode. and go to the cash flow button and start entering these numbers. So 1,000, enter, down. That was cash flow 0. Cash flow 1 is 2,000, enter, down. Frequency, I leave at 1. Cash flow 2 is 3,000, enter, down. Frequency, I leave at 1. Cash flow 3 is 5,000, and enter. Then I go to the net present value, and the discount rate is 5, so put 5, and enter, and down. And now this is telling me up here to compute, so I hit compute, and I get that the NPV, which is the present value, equals $9,945.03. Let's see, so that's answer C right here. Okay, so now let's look at question 7. So what's the present value of $2,000 discounted back 3 years if the appropriate interest rate is 8% compounded monthly? So the compounded monthly is going to be something that we'll have to deal with. So if we want to know the present value, that means this $2,000 is a future value. And it's discounted back 3 years, but it's compounded monthly, so I need to multiply this times 12. And so it's 36 months. And the interest rate they told us was 8%, but I need to divide that by 12. So 8 divided by 12 is 0.667. And then, so I'm solving for present value. The payment is just going to equal 0 because there's no information for that. So I go ahead and go to $2,000 and put that in my future value. 36 is in, and 0.667 is I, and 0 is the payment, and I hit compute the present value. And so I get $1,574.32. So, well, it's close enough. Answer B. Not sure why they put 51. It probably has to do with the fact that I just put 3 decimal places right here. So if you get something this close, an answer like this that's this close up here, then you go with the closest one that you can find. So let's look at the next question, number 8. So a bank pays a nominal 6% nominal rate with monthly compounding on deposits. What effective annual rate does the bank pay? So you can use the calculator if you go to the ICONV button, and we'll put in the nominal rate is equal to 6. The compounding periods per year is equal to 12 for monthly, and then we'll compute the effective rate and see what answer we get. So over here on the calculator, I hit the second key in interest rate conversion. The nominal rate is 6. I hit enter, and then I go down past this effective rate to compounding periods per year, and that's 12. And then I go back up and I hit compute, and so I get 6.17% is the effective annual rate, which is A. And you know, if you wanted to solve this by hand, then they usually call it the EAR, and they say, 1 plus the 6% in a decimal form divided by 12 raised to the 12th minus 1, and you would get 0.0617, which is 6.17%. So let's go to the next one.